Hello everybody again, it's Ms. Roberts here, and today I have a student with me. This is Mr. Hattersell.
Hi, I'm a student.
Today we'll be looking at enzymes. So we're going to do a little activity that's going to model enzymes. So what he's going to have to do today is use these toothpicks, and he's going to have to break these in half. But here's the rules for this. So here's the rules. Are you listening? Okay, so he is going to break each of these toothpicks. He has 5 of them on the table there, but he can only break one at a time with one hand, and it has to break completely in half to be able to count. So you're going to time yourself and see how long it takes you to break those 5 toothpicks. Okay, ready? Go.
Oops.
Okay, how long was that?
9.8 seconds.
All right, so in this experiment, we're looking at enzymes. So what do enzymes do for us?
Enzymes break down sugars.
Okay, so what part of this was the enzyme?
The enzyme was my hand.
Your hand was the enzyme, okay? And what did the toothpick represent?
The toothpick was the substrate.
The substrate, very good. Now, did anything happen to your hand, or is it okay?
My hand is completely fine.
Okay, so you could keep doing this, right?
I could keep doing this.
Okay, excellent. So that's a thing that enzymes do. They can keep going, and they can be reused over and over unless some problems happen. So we have a bucket of ice here for you, Mr. Harshell. So could you go ahead and submerge your hand in that ice for a couple of seconds? Just dive right in.
Yes, I can.
Okay, so sometimes enzymes are really picky about the temperature that they're in. If it's too cold or too hot, then they may not work very well. How's that ice going for you?
It's cold.
Is it cold? That's good. That's what we want. All right, so go ahead and try to break 5 more of those toothpicks. Start your timer again.
All right, here we go. That doesn't count.
Okay, how's your time this time?
15 seconds, 15.51 seconds.
Ooh, not a very good time there. So did it make it harder, that coldness in your hand and the wetness and everything, make it a little bit harder?
It did make it a little harder.
Okay, so enzymes are very particular about their temperature. They like it to be a certain temperature, not too hot or not too cold. If it's hot or cold, it can slow them down and they're not going to work as well. Okay, here's the next one. This one's a good one for you. So in our next one here, the enzyme's concentration has actually doubled. So there's more enzymes. So this is good for you this time. This time you can break 2 toothpicks at once.
Wow.
Okay, so time yourself again.
Okay.
Okay, how's your time?
8.1 seconds.
All right, good. That's an improvement. So if we have more enzymes, we're going to be able to break more substrate at a quicker pace. All right, next one. And this one,
Sorry.
this one's called enzyme denature. So enzymes, as we talked about in class and in your notes, enzymes are very particular about their shape. The shape of the enzyme has to match the shape of the substrate, just like a lock and a key or a puzzle piece. If they don't fit, then they don't work. So in this case, maybe there's too much acid or too much base inside of the body, and now the enzymes have changed shape. So for this time, you're going to have to cross these 2 fingers like this. So the shape of your enzymes have changed. All right, so now you're going to go and try to break those with your hand all contorted.
All right, hold on. You gotta come up with a plan.
Do your best.
This is tough.
You can barely pick them up.
Oh.
Oh, it's got to crack in half.
I think I got it. Yeah, like this. There we go.
Oh, you forgot one.
Oh no. All right.
How's your time?
28.4 seconds.
Ooh, that is not good at all.
Thank you.
So this time we saw the importance of the shape of the enzyme. The enzyme has to be the correct shape, otherwise it's not going to be able to go through and break down those substrates. All right, continuing along. In this time, we have some tape over all of our toothpicks there. This is called enzyme inhibition. So in class, in your notes, you learned about an inhibitor. An inhibitor is something that prevents the enzyme from getting to the substrate. So this time, you're going to have to get through that tape. Remember, you can only break one at a time. Okay, go ahead and start your timer. Peel off that
With
tape.
one hand.
With one hand.
Okay. Oh my goodness. Can't even find where the tape comes out. I hope everyone is enjoying watching this.
Oh, we are.
I broke the tape.
Not all of it. No, that's cheating. I see that.
I just needed a better angle. I can't get the tape off.
Maybe your enzyme would like to give up.
I can't find the tape.
Okay, go ahead and look at your time. What's your time?
Let's see, like 5 seconds? 51 seconds?
51, yeah, that's almost a minute there. So in some cases, in an inhibitor, the inhibitor may prevent the enzyme from working at all, and he may just be obsessed with continuing it on and may never actually get to it. Okay, the last one that we're going to look at, the last problem, is substrate concentration. So earlier we had a lot of enzymes, so the enzymes could go in and work on a lot of different substrates. But what would happen if our substrates, what happens if there's not enough of them? Now our enzyme is going to have to go find them. So since there's less substrates, now the enzyme is going to have to look around everywhere to find them. Okay, ready to start your timer?
Yep.
You remember where I threw them all?
Nope.
I don't either. Okay, go. I like how you're bringing them back to the table too.
Hey, a clean workstation is very important.
Hey, good job. You remembered them all. Okay, how's your time?
29.5 seconds.
Okay, so that's another one that's going to slow down our enzymes. Okay, so let's review what we talked about here. So what was your hand representing again for us?
My hand represents the enzymes.
And what were your toothpicks representing?
The whole toothpick represents the substrates.
And when you broke them in half, now it represents?
The broken toothpicks represent the products.
Very good. He's a very good student. This is why I chose him. So some problems, though, can occur with our enzymes. Usually they're not used up, so we can keep using them over and over. But we can have some various problems. We saw how temperature is an important part of this. If it's too cold or too hot, it can slow the enzyme down. We also saw that if we have lots of enzymes, then they can work very, very quickly by going through all the substrates. We also saw that if the shape of the enzyme changes somehow, they're not going to be able to break through those substrates very well. We also saw that sometimes inhibitors can happen, and if something is blocking the enzyme from getting to those different substrates, they're not going to be able to break them into the product. And the last one that we saw was if there are not enough substrates, then the enzyme has to go searching for them, and it's going to take it longer to go through all of those. So now you can answer all your questions about this, review your notes, and I hope this helps you understand enzymes. Thank you.